Good morning. Good morning. Thank you for that. So, when you take public speaking 101, you're supposed to know your audience. Judging by the number of cameras that went to the screen when Tarek showed the last PDH code, I think there's a lot of engineers in the room, right? Engineers? Keep your hand up if you actually design stuff. You're designers, right? Structural or otherwise, thank you. Contractors? It's okay if you're an engineer and a contractor, like my friend Justin. Concrete producers, welcome, my people. Yeah, you do. You need another arm, Justin. All right. So my name is Tarek. I work for Master Builders. We make additives used in the production of concrete. I'm a concrete guy. So 40 plus years. Big shout out to Jacob. He teed up some history. And set the stage for what we're going to talk about. And here are our objectives today. We'll define productivity, and really Phil has done that for us, so I'm going to thank Phil and show you one of his slides in a second. We'll look at some improvements through innovation. I think it's important to have some history, not because I've been at this myself for more than 40 years, but because it's not the same industry as when it started, and that's when many of our specifications and test methods derive. If they're if they're double digit or triple digit test methods, they're quite old, right? We'll look at measuring productivity, and then we'll look at what happens when we restrict innovation. And then we'll have a couple takeaways. See, I've already given Tarek a cold. I'm so sorry. Borrowing. Thank you, Phil, for this. Borrowing from Phil, what do we mean by productivity? Well, we want to make the most of our labor force, right? We're short of labor. Who's encouraged their children to become concrete finishers, other than maybe a summer or two so they sow their wild oats and then buckle down and complete their studies, right? We'd like to reduce conflicts with other trades. I'm not sure I can exactly relate that, but we certainly want to increase the value, service life, delivered product, faster schedule, product being a building or a structure, right? And we want to make our work processes less complex. If we never saw another RFI, if I never had to write another letter of explanation, well, I might be out of work if I never had to write another letter on behalf of a concrete producer. But anyhow, so let's look at the origin. We talk about productivity in the ready-mix concrete industry. We have to first think about the truck, right? So this is immediately following World War II. As a matter of fact, the truck on the right is in fact a surplus military truck mixer. Capacity was 4 cubic yards, and it had a separate gasoline engine and a chain drive mixer. So there's two motors, one to drive the truck and one to drive the mixer. And then there is one of those exact same models put into service. So 3 axles, carries 4 yards, 3 meters, and moves very slowly, okay? That's our baseline. And modern trucks carry 11 cubic meters. They might still have 3 axles. They wouldn't carry 10 or 11 or 12 yards. They wouldn't carry 8.5 meters, but they might have as many as 9 axles and carry almost a dozen cubic yards on an everyday basis. So same amount of time driving, 2.5 or 3 times delivered volume of concrete. Right? Same space on the road, essentially less global warming potential because we have 1 motor, not 2. We're using diesel. It's highly efficient. We've regulated the emissions. And so productivity has increased triple-fold for delivering the material. Let's think about placing the material, especially in structural applications. I don't mean tailgating, which is just dumping it out of the rear end of the truck, but I mean a crane and a bucket. So if we had a 1 cubic yard bucket and we had a very clever crane operator who had nothing else to do but deliver concrete that morning, that afternoon, that middle of the night, we could go at about 30 yards per hour. And obviously the taller we go, the higher we go, the longer that cycle takes. Now we can add multiple buckets so the time on the ground is less, but we need more space. Not necessarily safe. If you've ever been around, you know, we wear hard hats, now we wear helmets, right? If you don't have a helmet, that's a separate shout out, thank you. Hard hat, helmet, inside the cab of your ready mix truck, when that bucket falls, it's not gonna help you. And this slows down the concrete producer something serious, right? We're grabbing 1 yard at a time out of a 10 or 11 yard truck. Well, today we have boom pumps. They can effectively deliver 100, even 150, 160 cubic yards per hour. Now that's not the rated capacity of the truck. The pump can push 225, 250 yards per hour, but it has to be filled. So in a perfect scenario, which is not the case with the yellow truck on the left, that's one truck at a time in a small urban infill application. Tiny project, okay? But in the case of a large project where we can stage always having 2 trucks at the pump, always discharging simultaneously, ready to go, we can puke out a truck in 6, 7, maybe 8 minutes the most. We can get up to 150 cubic yards per hour if you've got a truck jockey and they know what they're doing, which means the crane can do something else. It can do all the other things that a crane needs to do, right? And it really turns around the truck mixer much more quickly, and we'll look at why that's important from a productivity point of view. And then the last innovation that I'd like to talk about is placing concrete by hand. You see on the left, I count 6 people in this picture, which is not that old because the part you can't see is the super sitting in his F-150, which looked to me to be a late model when I grabbed this picture. So there's 6 men there. And in effect, there's 3 people here, 4 if you count the guy on the shovel off to the left that I sliced in half. But one person is doing the work of 6 or 8 or 10 or 20, depending on the size of the screed. And how many people are bending over? How many people are bent at the waist? How many people are on their knees? None. None, none, none. So, you're all smart people. What do all of these pieces of equipment need? What do they all need? What do they all require to maximize their efficiency, their productivity? What do they need? Good operators. They need good operators. Yes, this is important. Although there are robotic trucks and there are robotic screeds. Consistent concrete. What kind of consistent concrete? Say again? The good kind of concrete. Who has the good concrete? Who sells and produces and sells bad concrete? Anybody? I don't know anybody that does that. Come on, guys. What do they need? They all need workable concrete. They all need some measure of workability, whatever that measure might be. Today, the measure is slump, we think, right? So, what does that tell us? Well, we have tables like this. I won't tell you where I grabbed this. People sent me specs. I have specs. You can find the world you live in. If you place foundation, somebody thinks you can live with a maximum 7-inch slump concrete. Okay? If you're a slip form paver, somebody thinks you need 1-inch slump concrete, but you said up to 3. So what's the deal here? Is it really 0? Is it really just 7? Who is restricting our ability to have workable concrete to maximize the efficiency of these pieces of very expensive equipment sometimes, and to speed up our construction so that our owner has a delivered project on schedule or ahead of schedule? Well, I submit it's agencies. I'm not going to name names, but they're responsible for military installations and infrastructure and schools and hospitals and industrial and commercial. And there are so many boilerplate specs that have been passed down that are, in all candor, they're ancient, and we need to stop and think. those of you that call on architects regularly or structural engineering firms know that 20 years ago, every firm had at least one in-house spec writer. In the Great Recession, those folks retired or went away, and they haven't come back. We have independent spec writers. We have people whose other duties as assigned is to write specs. We have the newest engineer or the newest architect in training assigned to write specs. And what do? They go grab stuff that's been done in the years before, and they say, how do we do that? So here we have, when Jacob put up the Roman cone, he said, when I saw the word Roman, I thought perhaps, I'll be happy to give you a PDF or the slides. It's no pride of authorship. Save your pixels. I thought he meant the Romans invented the slump cone. Now, some would say Duff Abrams sent it. He said Mr. Roman invented it. Either way, it's 1920. I did not take this picture. Mike Schneider took this picture. Jacob told you all the stuff, right? It really, once upon a time, people thought it measured water content. And I guess if we looked at very high water cement ratio, I'd learned that. This is my 43rd year. I'd forgotten that Mr. Abrams and Mr. Roman, working in the precursor to the Portland Cement Association, plotted water cement ratios of 0.25 to 0.75. Imagine 0.75. When do we do 0.75? Southern United States, patios, driveways, sidewalks all day long, fit for purpose. It's not designed that way, but it ends up that way. And so you get the slump cone, right? All right, it measured water content once upon a time. And it gives us some unto itself arbitrary determination of workability, which for paving, we see a box text is probably a better idea. And for high performance concrete, it's a combination of slump flow, visual index, VSI, and maybe an L box, right? But any of us that ever spent any time in a field know that we can manipulate that test. And as Jacob dug into distribution curves, it doesn't really tell us much other than people sharpen their pencils. So what do we have now? Well, we have water reducers that let us go up to 40% water reduction. Yes, I know that makes sticky concrete hard to trowel. I didn't put a power trowel up. I put a laser screed up. Smarter than that, right? However, the early materials that were used to make high-range water reducers retarded set something fierce. If we went past 10, 11, 12% water reduction, that's why the ASTM limit is 12% water reduction, we put concrete to sleep unintentionally, sometimes for days. We didn't want to do that. I was here then. I was very young, but I was here then. Now we can take out all kinds of slump, all kinds of water, and do all kinds of things with it, including make self-consolidating concrete, which, if you could afford the marginal cost in form work and spend the time on mixed design development, you could fly through nearly every project. And we don't just want to cover rebar, we want to fully encapsulate rebar. That's why SEC is so important. I live in California, I spend a lot of time on West Coast projects. That was mild steel reinforcement Jacob put up first thing this morning, okay? So let's look at how do we measure productivity. Well, ready-mix concrete producers, once they get past the 10th truck, they have more working capital tied up in trucks than they do in a plant. Trucks are now running on the order of $250,000 each. Hard to imagine. Trucks have a 7 to 10 year life. Concrete producers think about yards per driver hour. If you look at the industry data report, there from the NRMCA, and you have to be a concrete producer or no one, they look at yards per driver hour. That's where their money is. That's their measure of productivity. And they also look at how many uses of a truck: out, loaded, out, discharged back, ready to load again. That's a round or a turn. 4 is an average day. The 5th turn in a day and not exceed your driver restrictions on driver hours, now you start to make money, okay? Concrete pumping subcontractors typically look at yards per hour through the pump. That's how they measure their productivity. And they might roll that up to an annual basis. Is this machine still effective? Is there too much downtime to this machine? Is it time to swap it out? And note that most pumping contractors bill in half-day increments. So if we save 10 minutes per truck for retempering, well, if you've only got 3 trucks on the job, you're paying for a half a day, big deal. But if you're placing 400 or 500 yards and you're doing 40 or 50 loads, can I change that 5-hour rental to a 4-hour rental? I don't know. It's worth thinking about. What do place and finish contractors do? I asked a dozen very smart people. I don't know much, but I know a lot of very smart people. And I asked a dozen very smart people how they measure success. And I got a dozen different answers. And I won't quote any dollars and cents because some people were very open. I've been at this a long time. I have a lot of relationships, and people told me when they make money and when they lose money, and it's all on how productive are we, okay? So you can look at yards placed on a given day. If you're doing parking garages or mid or high-rise decks, if you're not doing a 200, 250, 300 yard placement every day, 3 or 4 days a week, you're not maximizing the crew time. You can look at square feet per day. Is it placed by hand? We're going to be limited in the high thousands of square feet for a hand crew with a mechanical screed. If we're using laser screeds, we can go to 50,000 square feet in a day. Just how fast can we get to concrete there? And then flat work is measured often on dollars per square foot or dollars per yard placed or man hours per square foot or man hours per yard placed. These are all metrics that sharp contractors measure. And a paving contractor typically thinks in terms of lane miles per day. And how long the day is how many miles they get done, right? Well, what is a ready mix? How does limited workability affect productivity in our concrete construction value chain? This is a slump rack or a wash down rack as opposed to the washout. That's at the end of the day. There's time at the slump rack. And this slump rack has stairs, which means the driver's going to pull up. He's going to go up and use the stairs instead of climbing his ladder. He's going to take that hose. He's going to add an unknown amount of water. Now, they'll tell you it's calibrated. They'll count from the time they turn the hose on and add water and tell you 1,000, oh, that's 10 gallons, 1,000. Is that one Mississippi or is that one Alabama or is that one Ohio? One Ohio, 2 Ohio? I don't know. I've measured it. When we tie a producer's hands around a workability measurement, we generate tremendous fear of rejected loads, which leads us as a concrete industry to trim water from each and every load. Pierre showed you that every concrete truck arrives on the job with an allowable amount of water that could be added, which now takes a minimum of 10 minutes. Let's be superhuman and say it's 5 minutes. It's really 10 to 12 minutes. Look at your timelines on all your discharge. The verified info is no different. From the time the truck rolls up until the time the discharge starts, because when we add water or add mixture, what do we have to do? Spin for 30 revs, 25 to 30 revs, right? So we have longer discharge times. There has to be a QC person or a knowledgeable person. We can't leave it to anybody there. And we get fewer turns, not turns of the drum, fewer rounds in a day. Or the day gets longer. Now the producer pushes into overtime. Driver hours are factored across every yard they deliver, not just the yards for your job. They're factored across every job. They may be specific. They may be very good at measuring their productivity and say, you turn my trucks around in 5 minutes. Tailgated, highly workable concrete, you hold on to my truck for an hour and a half. Curb and gutter, inching along. You're going to pay a whole lot more for delivery. You're going to pay a whole lot less for delivery. It's measured in real cost to the owner, right? So that's the effect of. Now, what about to the place and finisher contractor? Well, if we're going to measure slump, and we're going to measure slump every 50 yards or every 100 yards or every truck, we're really in trouble, right? We've got to slow down, and that means it takes us longer to do our job. And with lower workability, we need a bigger crew size or a bigger machine, right? We've got to up our crew, add to the crew, or a bigger laser screed, or both, right? It's harder to finish. The final appearance is not as good, which leads to rework, which costs us much. And if we're doing commercial or industrial floors, it's much harder to get the flatness and levelness. Okay? All right. For a concrete pumping subcontractor, biggest problem is increased pressure and slower time at the hopper, longer time to discharge, which decreases their hourly throughput. And if a mix is really hard, if it's not well designed, if it's not robust, regardless of workability level, it takes a lot of wear and tear on the truck, on the pump. Some unintended side effects. There's a cost to testing, time to test, especially when you have one or two bad results. You have one or two, the first or second truck are bad, now somebody's going to say, let's test every truck. Who's been on that job? Who's been on that job in the middle of the night? Who's been on that job in the middle of the night in really hot or really cold weather? Not fun. And so now we get back to the producer trimming, because you don't want to have a wet load. And now we need that time, which Pierre put a dollar amount on for you, right? And that dollar amount was trimming with water, not with expensive stuff. More unintended side effects. Rejected loads. What do rejected loads do? They interrupt our production. They have an unimaginable amount of administrative cost. There's the cost of waste disposal, and then there's the opportunity cost. That concrete truck has to go somewhere, and instead of delivering the concrete, it has to divert to landfill or some approved disposal site. There's a minimum of 2 hours in an urban location that truck cannot be productive. That has to be paid for somewhere, right? And then there's the intangible costs of lost trust, which leads to a blaming culture, which leads to an us versus them. Who's been on that job? Who's been on that job? Who's been on the job where we throw this guy off because his slumps were, well, what if the contractor was satisfied and we weren't measuring slump? What if? So, this is Phil's list. Oh, this is Phil's list with a few added. Okay, I've changed the top line. There's the definitions. Optimize field labor, reduce conflicts. I don't know about the reducing conflicts. I couldn't figure out that one. Increase value if we go faster, if we finish earlier, if we don't spend money on claims and change orders. And then what about these additional benefits that are not in the PRO definition of productivity? Reduce delays, reduce waste. We're trying to be sustainable. We're working our butts off to reduce the global warming potential and yet of a yard of concrete, and yet we think nothing about diverting 10 or 11 yards to where? You know, in many urban locations, it costs more to dispose of concrete than the purchase price of the concrete. That's hard to imagine, but it's true. And if the concrete is easier to work and doesn't have these artificial limits, then aren't the crews more satisfied? Aren't they a little bit happier at the end of the day? Isn't it a little bit safer? Aren't there fewer hazards? So some advice from two of my heroes. If you don't know these guys, you just haven't been around very long. That's it. That's key takeaway number one. If you remember nothing else of what I've said today, remember concrete slump should not be specified. End of story, almost. Key takeaway number two comes from a very smart person who said, oh, come on, nope, up. All right, Mr. Designer, Ms. Designer, you've put in a limit. You want some measure of quality that you think is determined by slump. Please be open to collaboration, which is a key tenet. It's a guiding principle of PRO. Be open to collaboration. Let's have this discussion, and contractors, go have that discussion early. All right. There's some acknowledgments to some very kind people. I'm not naming everybody. Jeff Davis and Joe Sesteric are retired. There's my contact info if you want it. And that's my 2 cents.